The one key thing that we have to pay attention to. And so we think about still getting our variable all by itself and positive. Okay? Just like what we did yesterday. Basic multiplication and division rules said that if the signs are the same, my answer is what?
Positive.
Positive. If my signs are different, doesn't matter which one's bigger, doesn't matter which one's smaller, my answer is always what?
Negative.
Negative. So we got to remember that. Those are key things. I don't know. Let me check here. No. It's not gonna help me on the wrong page. Okay, we do have some of these. So, realistically, at the beginning, real simple problems, just like yesterday. Except now we just do them with multiplication and division. So 9x is less than or equal to 54. Okay? So if the left-hand side shows multiplication, the opposite operation, again, inverse operation just means that I'm going to divide, and I'm going to divide by whatever number's in front of my variable. So in this case, I'm going to divide by 9, and whatever I do to one side, I do to the other side. My 9's cancel each other out, leaving me x is less than or equal to what?
6.
6. Pretty simple, right?
Yeah.
Again, if I have to graph it, okay, open or close dot.
Close.
Close because again, the equal sign. And which way do we shade? To the left, right? Again, if it's where the variable comes first, then we can use the sign as kind of a cheat. And it points that way, all right? So this would be the basic multiplication problem that you would have to use division. Here's my basic division problem that we're going to have to use multiplication. So again, division is usually shown to us by a fraction. So when we take that fraction, we're thinking of it as division. And so the opposite of a division is multiplication. I'm going to take and multiply by whatever's in the denominator. So I'm going to multiply by 9. And realistically, I'm going to put that 9 over 1. Whatever I do to one side again, I'm going to multiply by that same thing on the other side. But why do I write it this way? Because diagonally, they cancel each other out. And so then we end up with d is greater than what? 36. And so again, the only difference between my shades is now we have an open circle, and we're going to shade to the right. Okay? Any questions with those? Hopefully that's very, very simple. So, the challenge problems, or the things that we have to look at, are when I have a fraction with my variable. So, remember back when we did this when we were talking about solving equations, we said, can I divide by a fraction? Yeah. Not really. Because instead of dividing by a fraction, we're going to do what? So again, this is kind of one of those things that you might have to write down again. If there's a fraction and it's being multiplied to the variable, instead of dividing by a fraction, because honestly you can't do that, we're going to multiply by the reciprocal. Remember us saying that before? What's the reciprocal?
Is it flipped?
Oh, it's 4.
Yeah, it's flipped, right? So remember, a reciprocal is to flip a fraction. So again, when we talk about flipping the fraction or taking the reciprocal, this is always the one, always the fraction with the variable. So just in case there's a fraction on both sides of the equal sign, one with the variable and one on the other side, you only take the reciprocal of the one that has whereas next to the variable. So again, as Ashton said, the reciprocal is taking this fraction and flipping it. So basically what happens is I want the numbers to be diagonal to each other, right? Anytime that we use a reciprocal, we look diagonal, and it should, when we multiply, end up being 1. And in this case it does, right? My 4's cancel out, my 3's cancel out. So I'm left with 1. Again now, whatever I do to one side, I gotta do to the other side. So when you do this now, you're multiplying by a fraction, and the first thing that we've said that we can do when multiplying by a fraction is what? Well, yeah, we're doing that process right now, keep change flip. When I actually are ready to multiply though, what's the first thing that I can do before I actually multiply? Reduce. In which directions can I reduce? Both diagonals, or even up and down. But most of the time we're not going to probably have to do it up and down. So again, you don't have to do this, but it's going to make your number smaller. So if you want to do it, that's fine. If you don't, you can just multiply, but then you're going to have to reduce at the end. So in this case right here, I'm looking diagonal, and my 3 can cancel out of 12, so I'm left with 4 there and a 1 down here. So remember then, once I multiply, or ready to multiply, I'm going to multiply both the top and the bottom. It's different than adding and subtracting. We don't need a common denominator or anything in this. So when I look straight across, what's left on the top? 16, and what's left on the bottom? 1, right? We don't need to write that 1. So we get 16. All right? Want to look at another one with fraction? Okay. Let's say 2/5 x. Let's make it negative 2/5. Oh, no, let's not do that yet. Is greater than 14. All right, try it out, see what you get. So take the reciprocal and multiply that reciprocal to both sides of the problem. So my reciprocal is going to be 5/2 in this case. So I'm going to multiply by 5/2 on both sides.
Reduce 14 and 2.
Reduce 14 and 2.
7.
My 5's and my 2's cancel out, leaving me x is greater than 35. How do we do?
Good.
Piece of cake?
Okay.
Alright.
So what I did was, I just kept it, and then I just put 14 over 1 times 5 over 2. So I just basically keep change flip and got the same answer.
Yep. Good to go. Alright, now, biggest thing. Big star here. Okay? This is the biggest difference from yesterday to today. If you multiply or divide by a negative number, okay? We'll show this in examples. You must flip the inequality sign. So in the original problem, if it's less than, you change it to greater than. If it was greater than, you change it to less than. You just flip-flop it. Okay? Every single time that you multiply or divide by a fraction. Or, sorry, by a negative. All right? So, let's look at some of these. So we make it easy. Negative 7x is less than 49. Okay? So again, I'm going to divide by the number that's with the x. So when we talk about dividing by a negative, it's when the bottom number is a negative. And again, whenever I do it to one side, I got to do it to the other side. So when I have a negative number on the bottom, I do my division like I would normally do, so what do I get when I divide 49 divided by -7? -7. But because I divided by that, I have to switch my inequality sign.
So X is greater than.
So x is greater than -7. Exactly right.
Remember that from last year.
You remember that? Perfect. Okay? So the ones where it kind of gets confusing for some people is when we do a division problem. So a lot of the times, like in this example up on the board, they have negative s divided by 3 is less than or equal to -9. If they write the problem like this, because remember, if I have a fraction, I can put my negative sign on the top, on the bottom, or out in front, and one negative makes the whole thing negative. So that's negative right now. I would always put my negative either on the top or the bottom. Okay? It doesn't really matter here, but if I have a choice, I'm going to put the negative symbol with the number. Okay? So now, when I go through my process, again, this was division, so I'm going to multiply by my denominator, which is -3, and I'm going to multiply by -3. So again, my rule says if I multiply by a negative number, again, these cancel out, I'm left with my s, but my symbol has to get flipped. And then what do I get over here? Positive 27, because two negatives make a positive, right? But notice, this is the big thing right there. We have to switch that. And then again, if you have to graph it, you just graph it like it's normal. So you can basically put that negative wherever you want it, essentially. But I would always put it with the number. Okay? All right with that one? Now, here's one real quick that for some reason really bothers people. Is if I have even just negative x is greater than 14. Is that okay to leave as an answer?
No, because
the variable.
Because the variable is, right? So how do I make my variable positive? Divide by -1, exactly right. So again, whatever I do to one side, I got to do to the other side. But because the bottom number is a negative, I have to switch my inequality sign, and it turns into -14. But for whatever reason, people start going really fast, and they kind of lose track of what they actually have to do here. Okay? So, a lot of the same thing that we did yesterday, except that obviously we're doing multiplication and division. But then this rule right here is very important, and then don't forget about the reciprocal rule. Okay? Yeah. Questions? So you still got about 15 minutes. You can get a lot of your problems done here.